When it is windy, it can feel colder than it actually is because your body loses heat fast. This formula is what the National Weather Service uses to calculate the effective temperature, adjusted for wind speed, also known as the wind chill. If it's a little cold, the NWS issues a wind chill advisory, but if it's really cold, it's a wind chill warning. Let's see the code that calculates the wind chill and indicates advisory or warning as appropriate. The animation will visualize what each snippet of code does and how it all fits together. Python programs start running code at the top. This first line is actually multiple smaller instructions. The computer will first evaluate the right side of the equal sign. This input function will display the provided text to the user in the computer console or terminal, and then wait for the user to type something in and hit enter. Assume the user types in -1 for the temperature and hits enter. In order to compute the formula later with this value now, it must be saved into the computer memory. This is achieved using the temp equals part of line 1. This instruction tells Python to save the input from the right into a variable called temp, short for temperature, on the left. When Python creates a variable, it finds some free computer memory, labels the space with a name provided by the programmer, temp in this case, and then assigns it a value, such as the -1 the user typed in. Programmers must put data into variables, just like chefs use bowls and cups to hold onto ingredients. There's a small problem with the data in the temp variable. See the quotes around -1? Those quotes mean the temp variable has the string data type, which cannot be used to do math calculations. The input function always returns a string with whatever the user typed in. It is up to the programmer to convert the string into the appropriate data type. This is the goal of line 2, which makes use of the float function to sort of chop off the quotes from our data. The right side of line 2 passes the value from the temp variable into the float function, converting it to -1.0. Then the equal sign saves the transform value back into the temp variable on the left. Rather than having the input and float functions on separate lines, both can go on the same line, as in line 3. Python will start inside parentheses, so the input function is evaluated first. This shows a prompt to the user, asking them for a wind speed, and waits for the user to type something into the console, such as 6.5. That string, 6.5, is then passed into the float function to convert it to an actual number. The float, 6.5, is then saved to a new variable called wind due to the equal sign operator. Now that the program has 2 inputs for our math formula, the wind chill formula can be calculated. In principle, a programmer could compute the entire formula in one giant line of Python code, but here it is broken up over a few lines to explain things more clearly. The operators on line 5 respect the order of operations you may remember from math class, so multiplication happens first. Python takes a copy of the temp variable and multiplies it by 0.6215. Then it adds that result to a copy of the wind chill variable and then assigns the result back to the wind chill variable using the single equal sign, overwriting what was there before. Order of operations are important on line 6 as well. The double star operator means exponentiation. That is, it raises the value in the wind variable to the power of 0.16. After the exponent is calculated, the result is multiplied by 35.75. Then, that result is subtracted from a copy of the wind chill variable before being saved back into the wind chill variable. Line 7 has an example of the plus equals operator, which is a shorthand operator. These could have been used to make lines 5 and 6 a bit more succinct. Because the wind chill variable is being added to or subtracted from, line 5 can be rewritten with a plus equals operator, and line 6 with a minus equals operator. These operators will do exactly the same thing as the long version, but are less typing. For the plus equals operator on line 7, Python is going to compute the entire right side of the formula before adding it to the wind chill variable and saving the result back into the wind chill variable. Order of operations says to calculate the exponentiation first using the wind variable, and then multiplication is done from left to right. This result is then added to the wind chill variable, completing the formula. The calculated wind chill is about -13.7 Fahrenheit. Is that cold enough for an advisory or a warning? Rather than having a human take a look and make a decision, an if statement, also known as a conditional, can ask yes/no questions about the data. On line 8, the question is if the Windchill variable has a value less than or equal to -25. If you are writing your own conditionals, note the colon after the condition. In this case, the question is no, or false. Had it been true, Python would have run the indented code on line 9, but because the answer was false, the computer skips to line 10. On line 10, there's an elif statement, which is a follow-up question that is asked only if the if statement on line 8 was false. The question is if the Windchill variable is less than or equal to -10. This condition is true, so Python will run any indented lines that follow the elif, meaning it runs line 11. The user is shown a message, Windchill advisory, and the contents of the Windchill variable. Python skips any remaining elifs or elses, which means it hits the bottom of the program and terminates. When the computer finishes running the program, all variables are cleaned up from the computer memory. One of the useful things about computer programs is they can do different things when their inputs are different. That's the point of the if, elif, else structure on lines 8 through 13, to give different messages for different weather conditions. How does the program behavior change when the user runs this Windchill program the next day with different measurements? The input functions on line 1 and 3 wait for the user to type in the temperature and wind speed, and the float functions convert the typed-in strings into decimal numbers so the math formula can be calculated on lines 4 through 7. Especially on lines 6 and 7, it's important to remember Python follows an order of operations. It calculates the exponentiation first, and then the multiplication or division, and then the addition or subtraction. Going into line 8, the Windchill has been calculated to be -28 and change. Python now asks a question about that variable. Is it less than or equal to -25? This is a true statement, so Python will run the indented blue code, displaying the Windchill warning and the temperature. Then, Python will skip the elif and else statements because it's already found one true statement in this conditional chain. Thus, the program flow reaches the end and terminates. This program showed off how programmers can write Python code to do tedious and complex calculations using those variables, functions, and operators. Then the computer can make decisions based on those results using if, elif, and else statements. These are some of the fundamental parts of any computer program, so it's important for you as a programmer to understand what they do and how they fit together to make your own programs. Happy learning!